With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A current carrying loop in a uniform magnetic field will experience if you have to see your force and torque is asked whether it will be zero or non-zero. So if I talk about the uniform magnetic field, so let's take any random structure wire, and let's say in the wire the current is flowing in this direction, and let's say the magnetic field is in this direction, right? So if I talk about the length, so you can see the length is not linear, right? So if I talk about the force on any current carrying wire, magnetic force, it is equals to I times of L vector cross B vector. But here if you see the L is not a linear, it is a curve, right? So if I draw a vector, L vector, it will be from one point to another point. It will be in this direction, directed in the direction of current. So this will be here the L vector, right? So this we can do in case of uniform magnetic field only. Now you can calculate the work done, like a force on this wire by getting this L vector, right? So L vector will be from initial point to final point. And if you see, if I draw a loop, right? If I say, let's say this is the loop, any random shape loop, and in this loop the current is flowing in this direction, magnetic field is again in this direction, right? So here if you see the L vector, if you wanted to see the L vector, so if you start from this point and end to this point, right? So the final point is same as that of the initial point. So basically in this situation the L vector, it will be 0 because the final point is same as the initial point. So let me write down this. Final point is same as that of the initial point. Initial point. So if you see here, you can also understand it by breaking it into two parts. Right? If you break this into two parts, so you will get two L vector equal and opposite. The one L vector for the left part and it will be like this. Another for the right part, it will be like this. So you can see the L vector, the two L vector are equal and opposite. So if I say this is the L vector, this is the L dash vector. So I will write this L vector is negative of this L dash vector. So if you calculate the forces on the two parts, the part 1 and the part 2, you will get equal and opposite. You can check it. If you see, if I write down the force on the part 1, it is like I, current is same, right? So I, and this is the force on the part 1, force on the part 2, L dash, right? So L dash is minus L. So if you take minus sign, you will get the same force as that you got in the first part with negative sign. So this is minus V1. So basically the net force, that is FV1 plus FV2, that will be 0. So we got to know that in a loop the net force will be 0, but if I talk about the torque is magnetic moment times of this. So if this is a loop, right, so we can write down the magnetic moment is this. Magnetic moment is current times of area, right? Current times of area is the magnetic moment, which is not 0, neither this is 0. So torque will not be 0 here. So force will be 0, torque will be non-zero. So if you see the option present here, only torque. So B is the correct one. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.